Marker.
Let's look at variation types of problems. There's different types of variation. There's direct variation. So as one variable increases, so does the other one. There's inverse variation. As one variable increases, the other one decreases, or vice versa. Joint variation, which involves multiple variables, whether they increase or decrease to affect a variable. And then a combination between direct, inverse, or joint. So the keywords we need to look out for in all of our questions is, do you see the word direct, inverse, joint, or do you see multiple ones to assume a combination? Number one, assume y varies directly as x. If y is -4 when x is 2, find y when x is -6. So what keyword do you see here with this problem?
Varies.
Varies what?
Directly.
Directly. So I'm going to use direct variation, which is y equals kx. Now note each of these has a k. It's going to be some constant that's going to be the same throughout the entire problem. So first, looks like I'm given y and x. That means I probably need to find my k value here. Because as you notice, it takes away the y value, and I'm just left with an x. If I were to plug an x here, then I'm missing the y and the k. So let's solve this first half, where y is -4. So -4 equals, x is 2, and I don't know what k is. So I'll just leave that as k. So -4 equals 2k. Now, looks like I have enough information to solve for k. So 2 times k, the opposite of multiplying by 2 is divided by 2. So -4 divided by 2 leaves me with k equals -2. Now I have my constant value to where if you happen to take away any one of these variables, I can still solve it. As in the case here, find y when x is -6. So y equals x times k, where x is -6 and k is -2. And I get -6 times -2, which gives me y value of 12. So y equals 12. That's how you're going to solve each and every one of these. You're going to have to first find your k value so that when they take away a variable, you can finish the rest of it. So go ahead, while I take attendance, assume that y varies directly as x. If y is 80 when x is 32, find x now when y is 100. So, number 2, y is 80. 80 equals kx. I don't know what k is, but it gives me x is 32, so 32k, which means I need to find out what that k value is. So 80 divided by 32, 2.5, so k is 2.5. Now I need to find x when y is 100. So 100 equals 2.5 times x. And now divide by 2.5. So 100 divided by 2.5.
So you just divided?
Yeah. Opposite of multiplying by 2.5 is divided. Gives me x equals 40.
I understand.
Alright, so number 3. Assume that y varies inversely as x. If y equals 16 and x is 4, find y when x is 6. So now, my keyword here is inversely related. So I'm going to use my inverse formula. Y equals k over x. First part of it gives me y is 16. So 16 equals x is 4. So k over 4. Again, all of these we're going to solve for k first. So the opposite of dividing by 4 is multiplied by 4. 16 times 4 is 64. So k equals 64. Now I want to find y when x is 6.
It was inversely. Okay.
So y equals k over x. K is 64 over x, so it gives me 6. That equals 64 over 6, which is
To the decimal?
It's a decimal, I'll leave it as a fraction, 32 thirds. 32 over 3. Simplified fraction. So now let me have you try number 4. Assume that y varies inversely as x if y is 27 and x is 12. Find x when y is negative 12. Let's see.
Let's go.
Keyword here is still inversely, so I'm still going to use the y equals k over x. So I'm given the y as 27, so 27 equals k over my x value, which is given as 12. Need to find k. K equals 27 times 12, which is
Yeah,
324.
And I divided that by negative 12.
Now, find x when y is negative 12, so negative 12 equals k, which is 324 over x.
Make sure I did.
And you can do some cross multiply. I'm going to multiply negative 12 by x. Then I have to divide by that negative 12, so 324 divided by negative 12.
Make it 27.
That sounds about right. Yep, x equals negative 27.
I did it like that, but I did it as the same method from above. So I just
Let's look at the other two types. Assume y varies jointly with x and z. If y is 20 when x is 2 and z is 5, find y when x is 14 and z is 8. So we got a little bit more variables here. Keyword to point out is jointly.
jointly.
So we're using this y equals kx z. Where again, I need to find my k value. I'm given y is 20, x is 2, z is 5, and I need to find k. So if 20 equals 2 times 5 is 10k, divide by 10, k is 2. Now I can find y when I'm only given x and z. So y equals x, which is 14, z, which is 8, and k, which is 2.
Dang.
So 14 times 8 times 2 gives me a grand total of 224.
You just multiply all of those.
Yep. So now it's your turn. Assume y varies jointly with x and z. If y is 12, x is 2, z is 4, find x when y is 9 and z is 6. So same thing, find your z, your k first. So you can solve it when you're missing a variable. So let's see, y is 12. So 12 equals x is 2.
12 divided by 8.
Z is 4, yep, k, so 2 times 4 is 8. I'm looking for 12 divided by 8,
You get 1.5.
1.5 for my k.
I was about to put, oh, it's K already there. Tripping. 1.5.
Now I need to find x when y is 9 and z is 6.
So would you multiply those?
So let's see, y is 9, so it's a y equals, so 9 equals.
Mm-hmm.
I have z, which is 6. I know my k value, which is 1.5, and I'm missing my x. So it's going to be 6 times 1.5, which is 9. So I get 9 equals 9x. Then solve for x, you get x equals 1. X equals 1.
So it was 9 divided by 9?
Yes, 6 times 1.5 is 9. So then you want to divide that with 9, and you'll get a 1.
I got this.
Now for this next one, I'm going to change up a little bit.
What did I say?
I'm going to switch these out, x, and this is going to be x. So assume y varies directly with the square of x and inversely with z. So what kind of variation do you think this is? Combined, right? Because I'm directly and inversely. It's a combination. Y equals k times x over z. Note that the one that gets inversely related, z, is on the denominator. Anything inversely with a variation goes on the bottom. Now there's one more change I have to make. See, these aren't actually formulas, set formulas, they're more like guidelines. They can be changed. Assume y varies directly with the square of x. So I need to go here to my x and square it. So my formula for this problem is y equals kx squared divided by z. Now I can solve it. So if x is 6, when y is 2 and z 8, so let me plug it in because I need to find my k. So let's see, x is 6, so it's 6 squared. Don't know the k. Z is on the bottom, z is 8, and that equals y is 2. So I need to multiply 8 by 2, I get 16, and divide that by 6 squared, which is 36. With these combinations, you're going to get weird k values, such as I get 4/9. So k equals 4/9. That's just the way it's going to work. Now I can find x when y is 1 and z is 12. So x, y is 1, so 1 equals k, which I know what k is now, 4/9. Find x. So x, and it's squared, and z, 12. So now, multiply by 12, gives me 12 over here. 4 over 9 is being multiplied, so let me divide 12 by 4 over 9. That gives me 27. And last but not least, to solve for x, I need to take the square root of 27, and we'll just leave that as x equals square root of 27.
That's a lot of steps.
Well, yeah, combination has a lot of variables in it. So there's kind of the basic layout of variation. What they truly look like in the real world is something like this. The pressure on a point in a liquid is directly proportional to the distance from the surface to the point. On a certain liquid, the pressure at a depth of 4 meters is 60 kilograms per meter squared. Find the pressure at a depth of 10 meters. Probably what you'll probably see on the ASVAB, something like this. What keyword can you point out? Directly, right?
Oh, right there, I didn't even see it.
Directly proportional. We are going to use the direct variation formula. Y equals kx. Now, unlike the previous problems, this doesn't give us what x equals what k equals. We have to figure out, well, k is going to be a number, so it's not going to be related to any kind of unit within here. So we got to figure out what is going to be our y, what is going to be our x. A good rule of thumb is anything before your word directly, that's going to be your y value. Note with math, is means equals. So what unit of measurement do you see before all of this? Pressure. So y is my pressure. That makes k is going to be my constant number. X has to be another unit of measurement, and I see that unit of measurement is going to be distance or depth. Now that I got a label, I can plug in my numbers. So the pressure at a depth of 4 meters is 60 kilograms.
So that will be 60 kilograms.
Yep, so y equals 60, and I have a depth of 4k. So that'll allow me to find my constant value for k. So 60 divided by 4 is 15. So now I know that my constant is 15. And I can solve the actual problem. Find the pressure at a depth of 10 meters. So what would you do? Y equals K, which is 15, times X, which is 10 meters. 15 times 10 gives me a pressure of 150 kilograms per meter squared. So there's your answer, 150. So just like the previous problems, it will be a two-step process. We define the K, and then you could find the solution.
Multiply.
Look at another one. The weight of an object varies inversely as the square of its distance from the center of the Earth. If an object 800 miles from the center of the Earth weighs 90 pounds, find its weight when it is 12,000 miles from the center of the Earth.
Inversely.
Very good.
Wow.
So our keyword here is inversely.
Y equals K over X.
Y equals K over X. What is going to be our measurement for Y?
If it 800.
What unit of measurement do you see before inversely?
The weight.
Weight. Very good. So Y is going to be my weight. And what will be the X? Distance.
Oh, so the weight is 12,000.
Now there's one more thing.
I'm tripping. The weight is 90.
If you pay close attention, what am I doing to distance? Square. So again, I have to modify this a little bit to Y equals K over X squared.
How
I'll
did
make
you
these
notice
numbers-
that, though? How did you notice that? Because
You just have to read it carefully. Yeah. I mean, technically, this is actually a really tricky one because notice this with my unit measurement. M squared. Technically, you have to square this as well, but I didn't want to get into that. That's a little too tricky. All right, so Y equals K over X squared. If an object is 8,000 miles, so over 8,000 squared, from the center of the Earth that weighs 90 pounds, so equals 90. Up here's my K, which I don't know, so let's try to solve it. It's going to be a very big number. I have 8,000 squared times 90. That's 576 with 7 zeros after it. 576 with 1, 2, 3, 4, 5, 6, 7. Now that we have our K, we can solve the problem. Find its weight when it is 12,000 miles from the center of the Earth.
so you divide.
So yes, now I have Y equals K over, and K is that long thing.
Bruh.
All over 12,000 squared. So divide by 12,000
And go. The thing for the grade variations of all forms.
squared, yes, equals 40 pounds. So there's a neat way of losing weight. You just travel away from Earth's gravity. At 8,000 miles away, you are 90. At 12,000 miles away, you are 40.
And when you come back, what will happen? You'll still be 40 or what?
No?
You'll get your weight back?
Yeah?
What? What?
Gravity.
That's crazy, bro.
All right, one more problem. This one's a doozy. The force needed to keep a car from skidding on a curve varies inversely as the radius of the curve and jointly as the weight of the car and the square of the speed. It takes 3,000 pounds of force to keep a 2,000 pound car from skidding on a curve of radius 500 feet at 30 miles an hour. What force will keep the same car from skidding on a curve of 800 feet at 60 miles an hour? So what are our key terms here?
Inversely
I see inversely
and jointly.
and jointly. So I'm going to be using both of these together, which means I'm a combination, which requires that z with it because it is jointly and not directly. Well, I already have a z, so let's just call that a w, I guess. So my formula is y equals kxw over z. So notice, why did I add this w? Because again, this is just guidelines of what it would look like. I have an actual additional variable here, so I need to add another variable. Let's label our variables. What's going to be my unit of measurement for the y? Before all of this, what unit of measurement do you see?
Distance? Unless you're tripping.
Right here.
It says force needed to keep a car from escaping.
Force, yeah.
Force? I thought I exchanged force with the word distant.
So this is my force. Notice inversely as the radius. So what letter would you use for radius? If it's inversely.
R?
What's that? No, okay. It is R. I could replace it with R, but which one of these up here?
Is it X?
It's not going to be X. Which one of these represents inverse?
W?
Okay. Or Z?
Okay. It's going to be Z.
Z is at the bottom.
Anything inversely is going to be on the bottom. K is never going to be one of your unit of measurements. It's always going to be some number. It'll just be some value. Now the top here is everything that is jointly related. I have a weight.
No way. There's no way that's with me. There's no way. There's no way.
That's what the.
I need program
Mm-mm.
I need you
Right now.
I
Just
thought
20
it was
I only
your
need
package
23.
there, bro.
Okay. I was going to give it to you later, but let me see.
if you want to do that, that's fine. I'm just trying to.
Okay, yeah.
Okay.
Look, I'm gonna see your package, bro.
No, you don't see those calculators right there?
I thought like backpacks, bro. Like backpacks, bro. So I didn't see.
Where were we? All right, so I know K is the number. I need to find my X and W. So let's see. I have weight. So I'll just call X my weight. And W is the speed, but it's got something attached to it, don't it? Speed squared. This is my speed. And I need to square it. So my formula is going to be y equals kxw squared over z. Now let's plug everything in. It takes 3,000 pounds of force, so that's my y. 3,000 to equal a 2,000 pound car. So my weight is k times 2,000. From skidding on a curve of a radius is on the bottom, 500, going at a speed of 30. And my speed I have to square, so 30 squared. So to solve for K, I need 3,000 multiplied by 500, and then divided by 2,000 times 30 squared. 3,000 times 30 squared. Again, with these
Is there a formula sheet
right here,
besides that's the only formula sheet?
Yeah.
yeah. Like I said, with these combinations, you're going to get a weird fraction for the K. K is 5/6. Now, let's solve the problem. Now that we know K, what force would keep the same car from skidding on a curve of radius 800 feet at 60 miles per hour? So I need the force, so it's y equals, I know K now, that's 5/6. What's going to be my weight? Notice it does say the same car,
Oh, then 30.
2,000.
Oh, 2,000. I'm fine.
Yeah, 2,000. It's going to be the same weight, 2,000. How fast is it going? 60 miles an hour, and then you just square it. All over the radius of 800. So it looks like you just got to do some calculator work. So 5/6 times 2,000 times 60 squared divide that by 800, gets you a grand total force of 7,500 newtons, joules, whatever that force is going to be.